All right, good afternoon, everybody. Welcome back. I hope you had a nice weekend. We're going to be looking today at lesson 30.02, part A, where we're graphing sine and cosine functions. We're going to be looking at the very basic function y equals sine of x and the other basic function y equals cosine of x, and then graphing transformations of them when there are vertical and horizontal stretches and reflections. I believe that this is page 4 of your lesson handout. So to begin with, if you were to plot graphs of y equals sine of x, f of x equals sine of x, if you want to use function notation, and y equals cos of x or f of x equals cos of x, you would see the following images. And I don't really want to get sidetracked into a discussion of how we can build these graphs. I guess, you know what the bottom line is you could do it using a table of values. So that if you took an x coordinate of 0, which is what I'm pointing at, and took the sine of 0, you would discover that you would get 0 for a y coordinate. So the y coordinate here is 0. If, on the other hand, you went over here and talked about pi over 2 for an x coordinate, and you took the sine of pi over 2, what you would discover is that you would get a sine of pi over 2 equaling 1. And then you could continue this procedure. You know, you could go to pi and discover that sine of pi is 0, and you could go to 3 pi over 2 for x and discover that y is negative 1. And finally, when you got over to 2 pi for x, you would discover that you're back at the beginning. And I'm doing this for a reason. It really isn't about how we can get the graph. I want to point out to you that when we take a look at those points that I've sketched, there is a pattern going on. And the pattern contains 4 pieces to it. If you listen to my words and you watch the video at the same time, there is a first part that goes up, a second part that goes down, then there's a third part that continues down, and a fourth part that goes up. And another thing I want to draw to your attention, or draw your attention to rather, is that this pattern gets repeated in both directions indefinitely. So we notice that we see the pattern here. We notice that the pattern continues in this location. We notice that it continues over here. So that up, down, down, up is very important to what's going on. This is called a periodic function. If you were to take a look at cosine of x, it is also periodic, but it's slightly off from sine of x. And I'll talk about that in more detail in a second. But if we start when x is 0, there is a down, a further down, a further up, and then finally the last up. So there's still 4 pieces. And that thing gets repeated elsewhere as well. Well, I'm dragging across pieces. I was hoping it would have come as one piece, but you get the idea that I can take that piece and I can replicate it in both directions. And I prefer to start at x equals 0 when I talk about the 4 pieces. So again, just to recap this point that I want to make that I think is an important point. Starting at the beginning, sine goes up, down, down, up. Starting at the beginning, cosine goes down, down, up, up. Now, we're asked to write out what the domain, range, amplitude, period, x-intercepts, and start point are. Some of this you should be able to do already, and the rest of it is basically new terminology. The domain we can see is x is any real number. And if I want to get really fancy, I can use that notation, which says x is an element of all real numbers. And when we take a look at y, I want to bring up my own graphs here just to show something to you, because I have the ability to put a little bit more information on them. So when I take a look at y equals sine of x, there it starts at the origin, goes up, down, down, up. I notice that there is a maximum value of 1 and a minimum value of -1. That's pretty important to what's going on here. Although the graph extends forever horizontally, it's trapped between or on those two lines. And for that reason, we are going to say that the range is y such that -1 is less than or equal to y, which is less than or equal to 1. And by the way, we can also say regardless, y must be a real number. That's a lot of dressing on that. What we're saying is y is between or equal to -1 and 1. Now the amplitude is a new term. The amplitude is the distance between the highest point and the middle of the graph, or between the lowest point and the middle of the graph. So in sine of x equals y, the amplitude is 1. The period is the distance. I want to go back to this particular graph. I'm going to get rid of everything except for that piece, and I'm even going to highlight it for you. Up, down, down, up. This distance is called the period. So however long it takes horizontally for the pattern to start repeating is the period, and we can see that the period is 2 pi. The x-intercepts, well, we can just look at the graph. We can see that they are 0, pi, -pi. Really what they are multiples of pi. Those are the x-intercepts. And the start point is the point on the graph where x equals 0. So the start point is at 0, 0. The start point, that phrase or that terminology for start point, isn't really crucial, but it's important for later. When we take a look at cosine, a lot of the information is going to be the same. The domain will be x as any real number. I will dispense with the fancy decorations on it. The range is still going to be from and including -1 up to and including +1. The amplitude is still 1. The period is still 2 pi. One complete cycle is down, down, up, up. The distance horizontally is what we call the period, which is 2 pi. You'll notice something, and I'm sorry I don't come up with this stuff, that the symbol we use for period is the letter K, and that letter K has nothing to do with the K that we've been using for vertical translations. When you look at the x-intercepts, and you might have to think about this a bit, the x-intercepts are going to be pi over 2 plus multiples of pi. And the start point this time is at the top, 0, 1. So you need to become kind of familiar with those graphs. Now what we're going to do is we are going to be applying vertical and horizontal stretches and reflections. So we're going to be graphing from y equals sine x, we're going to be turning it into y equals a sine bx. And cos x is going to turn into a cos bx. I'm not going to write this down for you. You should remember this even though it's been a while. A is a vertical stretch factor and sometimes responsible for a vertical reflection. B is sometimes responsible for a horizontal reflection, which quite honestly, I don't think we'll get negative B's here. But B also leads us to the stretch factor. Now don't forget, the horizontal stretch factor is the reciprocal of B. Okay, so in each of the following, a trigonometric function is given. Identify the properties listed for each function. Okay, so we want to know the domain and the range and the amplitude and the period. Well, first of all, let's just get this out of the way. The domain for any transformed sine or cosine function is always going to be -infinity to infinity. If they both extend from -infinity to infinity before being stretched or reflected, It doesn't matter how they're stretched or reflected, they're still going to extend across that infinite range. I shouldn't say that, across that infinite domain of numbers. Now, what about the range, the amplitude, and the period? Well, what I'm going to do, and I'm not going to, I think, do this with every single one of these, but let's take a look at the graph. And you're going to follow along up here. If I want to know what the graph of y equals sine of x looks like, well, I know that there is a maximum value of 1 and a minimum value of 1. I know the start point is at the origin, and I've put a very large dot there so you can see it. And I know that sine starts there and goes up. And I know that it will go up, down, down, and up in the period of 2 pi. So I know what this graph of sine of x looks like. If I want to know what 4 sine of 2x looks like, the 4 is the a value, which means things are stretched vertically by a factor of 4. Well, that means it's going to be bound by these two lines. Instead of going up to 1, it's going to go up to 4 times greater, which would be 4. I do know as well that sine starts at the origin, and the fact that I stretch things horizontally or vertically doesn't move this start point. Now we need to talk, and by the way, it's going to be going up. Now we need to talk about the period. Now this whole graph, this whole up, down, down, up, takes 2 pi to happen, and we have a 2 in front of the x. So I'm going to go back to my notebook file for a second, and I just want to indicate on here, just so you know, that what's happening is we have a vertical stretch by a factor of 4, but we have a horizontal stretch by a factor of 1/2. So in the end, that whole up, down, down, up is going to occur over half the distance it did before. So it's going to pass through those points. It's going to go up to the next point, down, down, and up. So what it's going to look like is that. So what we've done is taken that blue graph and stretched it vertically by a factor of 4 and horizontally by a factor of 1/2. By the way, we can see right now the amplitude is 4 and the period is 1/2 of what it was. Not that it matters, but of course this graph extends and it keeps repeating. So we know that the period now is pi and the amplitude is 4. Now what we would like to do here, let me write this down first. What we would like to do, the amplitude is 4 and the period is, we said pi, is come up with some kind of rule. And the rule is going to be very simple for the amplitude. The amplitude is whatever number is in front of the function. Because if sine goes up to 1 and we multiply that by 4, it's going to go up to 4. If we multiply it by 8, it's going to go up to 8. The range we can see from the graph goes from -4 up to +4. So the rule that we want to try to develop is the range will always be from the negative of the amplitude to the positive of the amplitude. So the next example, we'll look at the graph again on a computer. Let me just close out some of my windows. So this one is -1/2 sine of 3x. So again, if I looked at sine of x, we know what it looks like. It goes up and down between 1 and -1. And by the way, this I put in degrees because the function has a degree symbol on it. So if I'm interested in the graph of this, -0.5 sine of 3x, well, things are going to be stretched vertically by 0.5, which means the maximum and minimum will be at 0.5 and -0.5. The start point for sine is at the origin, But instead of going up, the graph is going to go down. Not that it matters for finding the amplitude or the period. It's going to repeat every 120 degrees. Now you need to think about this. Sine of x repeats in 360 degrees. And if we have a 3 in front of the x, that means we're stretching horizontally by a third, which means we take a third of 360, and that tells us what the graph will look like. Now we can see there that the amplitude is 0.5 and the period is 120 degrees. So we pretty much have enough information to answer this question. The amplitude is 0.5. The period is 120 degrees. The domain is x is any real number. And of course the range is negative 0.5 to positive 0.5. Well, let's see if we can develop some rules now. Clearly, the amplitude is related to that value of a, but the amplitude is going to be the absolute value of a. Because if a is negative, all that does is reflect the function, but it doesn't change the fact that it still stretches it vertically by that amount. Now, I don't know if anybody picked up on this yet, but the period is the regular period divided by b. We take a look at b in this question. b is equal to 2, which means if we take 2 pi divided by 2, it gives you pi, and pi is the period. In fact, we shouldn't even think of stretches here. Take a look at b. The period is 360 degrees over b. b is 3. Well, that's going to be 360 degrees over 3. And that gives you 120 degrees. So for the next two examples, I don't think I'm going to even graph them. We're just going to look at this and we're going to say that if, well, I'll show you the graphs afterwards. The domain is always x is any real number. What would the period be? Well, we're in degrees here in this, so the period is 2 pi. My mistake. The period is 360 degrees over 1/2, which is 0.5. And when you divide 360 by 0.5, you get 720. The period is 720 degrees. This graph is going to go up to positive 2 and down to negative 2 because of the vertical stretch factor. So the amplitude is 2. The range then is negative 2 to 2. And I can show you that graph. There it is. Notice that the start point is at the top. And it goes down. Cosine always starts at the top and goes down, unless it's reflected vertically. You can see the amplitude is 2. I can even put in these lines for you so that you can see them. And you can see that it goes down, down, up, up, but it takes 720 degrees, which means 720 degrees is the amplitude. Let's take a look at D. What I'm going to do is ask you to just pause the video and then write in, while the video is paused, write down what the domain, range, amplitude, and period are going to be. Just a word of caution here, there's no degree symbol, so we're talking about radians. So you go ahead and pause the video. And when you unpause it, hopefully what you discover is you got right answers. The range, the domain is any real number. The amplitude is 17.2. The range is negative 17.2, less than or equal to y, less than or equal to 17.2. The period is 8 pi. So that's the one I will explain. The period is the regular period of 2 pi over b. 2 pi divided by 0.25. 2 divided by 0.25 is 8, so you get 8 pi. Just quickly show you the graph. By the way, a cosine graph would start up here at 17.2 and go down, but since there's a negative in front of the function, so that would be if it were positive, since there's a negative, it has to start at the bottom going up. So this is what the graph looks like. Period is 8 pi, amplitude is 17.2. Should make sense to you. So what we have learned, I hope, and it's difficult with these videos again, is we have some rules. First of all, the domain is any real number. The amplitude is always the absolute value of whatever A is up here. Whatever A is in this function, or whatever A is in this function, the amplitude is the absolute value of that value of A. The range is the negative of the amplitude up to the positive of the amplitude, and there is a typing mistake here. I don't know if it's in your handout as well or not. We should definitely have or equal to on these. And the period is always 2 pi over b if you're dealing with radians, or 360 over b if you're dealing with degrees. Okay, so we've got a few real quick questions to look at now. Write a sine function with an amplitude of 1.8 and a period of 12 degrees. So I want to start by looking at this period equals 360 degrees over b. If you cross multiply this, you get period times b equals 360. And then if you divide by k, which is the period, you get b equals 360 over the period. And this is pretty important that you listen carefully to what I'm going to tell you. If you know b and want to find the period, then take 360 divided by b. If you know the period and want to find b, take 360 and divide by the period. So basically what we have to do here is take 360 degrees divided by 12, and I believe that gives us 30. 36 divided by 12 is 3. Yes, it gives you 30. So the amplitude is 1.8. That means A is 1.8. Little a is 1.8. And b is 30, which means the function is y equals 1.8 sine 30x. Now, could we have put negative 1.8? Sure. You can use positive 1.8 or negative 1.8. Number 3, write a sine function with an amplitude of 6 and a period of pi over 7. Well, let's find out what b is first. It's going to be 2 pi over the period, which will be 2 pi over pi over 7. When you divide by a fraction, you multiply by the reciprocal, and what happens here is our pi's cancel, and you're left with b equals 14. A is 6. Or negative 6, it's entirely up to you. So one function would be 6 sine 14x. I realized something with the previous example. We should probably have degrees on this in the equation. And determine the equation of each of the following functions. Really, everybody, question 4 is like question 3, but you have to find a and b from a graph. So the amplitude we can see is 3, which means lowercase a, you can use 3 or negative 3. B will be 2 pi divided by whatever the period is. the graph, so you need to look at the graph and determine what the period is. Well, I can tell that the period is pi because from the start point, which is here, I have to go through 1 up, 2 up, 3 down, 4 down. I have to go through 4 pieces, and I can see that from the beginning to the end of that cycle is pi. So I can write now that b is 2 pi over pi. The pi's cancel, b is 2. I mean, all you have to do once you figure out a and b are put them into the equation. Now, this has a start point that's not at the origin, so it's not a sine function. If it were cosine, it would start at the top and go down. This starts at the bottom and goes up, which means a is actually -3 here. We have to use -3. Sine of bx, which is 2x. Whoops, cos. If it were sine, it has to start in the origin, at the origin. And if it's positive cos, it starts at the top and goes down. If it's negative cos, it starts at the bottom and goes up. And this one, well, this is a sine function. We can see it starts at the origin. And because it starts at the origin and goes up, we can use a positive number for a. You can see that it goes up to 6 and down to -6, so a is 6. The value of b would be found by taking 360 degrees over the period. I can see here up, down, down, up happens at the 90-degree mark, which means b is 360 over 90 degrees, which is 4. B is 4. Really, you're just using the formula y equals a sine bx, and you're loading these two numbers in to get y equals 6 sine 4x, and that's the answer. Again, it's hard, I'll get used to this. It's hard for me to judge my pace. I feel as though I might have rushed things a little bit, but I guess you can pause the video if you like. Just a couple of reminders here. Tomorrow, we've got our Google Hangout. This isn't a criticism, and maybe it's because the stuff you did last week was really easy, but in the Google Chat Hangout last time in this course, I think there were only 2 people that showed up. And that worries me a little bit. So if you have any questions, just log in. Don't even have to you log into your account, but go to that web page that I've given you the address for. I'll post it again along with the link to this video. Here's your assignment. Don't forget that you have an assignment that's due to be turned in by the end of the day today. I've got a lot of them, but I don't have nearly all of them, so make sure you get that done. And anytime you're asked here to sketch a graph, you certainly don't need to. It's all about you recognizing the connection between the amplitude and A, and the range and A, and the period and B. So I hope that was helpful. Good luck with those questions. Don't forget, if you have problems with them, you can drop by the Google Hangout tomorrow afternoon during period 3. Have a great rest of the day, you guys. We'll talk to you later.